Highway construction. This video is regarding the construction procedure involved in the subgrade. Now here there are different equipments involved in the highway construction for the earth moving and also for compaction. The dozers, wheel loaders, hydraulic excavators and vibrator compactors are involved. And for road pavement equipments, rollers, road pavers, asphalt, concrete plants, and concreting. There are even in the road paving equipment there are different compactors involved too. Concreting equipment, batching plant, mixers, concrete pumps, transit mixers, dumpers, concrete placers are used. Uh, Now before we start with the preparation of soil and why we need to go for soil stabilization, first we need to understand why we need to do the earthwork. Uh, After completion of profile leveling, maybe by any of the means, maybe by totalization or manual means, mm, uh, while analyzing, we will be comparing the centerline elevation. Once you fix the centerline, you will be knowing the centerline levels, and based on the requirement of the project and based on the design needs, we will fix the formation level. Once the formation levels are fixed or formation line is drawn, uh, the next step is to analyze the sections where there is a need of earthwork. Obviously, in all the sections there will be need of earthwork, but in some sections it will be involved with cutting, and in some it will be involved with filling. So, in any of the cases, we need to work on earth. So yeah, maybe we will be involved in cutting or we will be involved in filling. At the end, we will be in need of the subgrade with sufficient support, or the earth with sufficient support, so that it can handle the stresses coming from different pavement layers which have come from traffic. Now, to make that subgrade ready for taking the stresses, we need to understand the existing properties of the soil subgrade. Or if the existing strength of that soil is not sufficient to take the stresses, then obviously we will be in need of increasing the property by soil stabilization. Or if this strength requirement is more, and even if the budget constraints, if there are no budget constraints, then definitely we can go for uh, replacing that soil from a borrow pit soil with sufficient strength. Then compaction is done. In case if we are in need of increasing the existing soil strength, then there are different methods of stabilizing the soil. Stabilization of soil is nothing but the improvement of different soil properties. Here, soil stabilization is required to upgrade the low-cost roads to higher specification without involving appreciable wastage, and the construction cost can be reduced by selecting local materials for construction of lower layers. As it is one of the lowest layer of a pavement structure, that the total stresses involved in that section will be less compared to the top section, so that uh, if we try to reduce that cost in the lower layers, and if we can improve that in upper layers, then it will work well, because the stresses will be high in case of upper layers. These are the different soil stabilization methods: mechanical soil stabilization, soil cement stabilization, soil lime stabilization, soil bitumen stabilization, and there are many more varieties of soil stabilization method by adding admixtures like cement, bitumen, lime, and there are many. And even there are different chemical based soil stabilizations too. So, these are the different methods involved in each of these soil stabilization method. What are the existing properties of soil, and what are the different factors affecting the mechanical stability, and what is the mixed design of soil, mechanical soil stabilization, how it need to be done. These are the different properties: liquid limit and plasticity index value. And what is the construction procedure? And this is about soil cement stabilization. In a similar way, this is also explained. Just you can break it out. This is for soil bitumen stabilization. The construction of a soil bitumen layer. This is of a soil lime stabilization. Now comes the preparation of subgrade construction procedure. As I told you, once we are ready with the formation level, then we are very much clear that what is the exact level of subgrade. Once we are 100% sure about the level of a subgrade, the next step is to set out those points on ground. Set out those points on ground. See, after the site has been cleared, the work should be set out. This site has been cleared, it means there are different waste materials, vegetations uh, on the existing earth surface, so that need to be cleared, and then set out need to be done. So the set out is nothing but the marking and fixing the pegs on both the sides of the roads at the appropriate levels, and even marking need to be done. Then dewatering, if there are some uh, if that project area is a water stagnant area, then definitely that water need to be drained away, so that water need to be removed. Why? Because obviously when water comes in contact with the subgrade or any of the layers of the pavement, then definitely that affects the strength of that layer, which in turn or it may end with the whole structural failure of the pavement. That's why water need to be removed. And as per the specification of Indian Road Congress, the subgrade bottom layer level need to be at least 1.2 meters above the water table level, so that even the pore water may not reach. So this is some precautionary measures taken to um, improve or to maintain the stability of that subgrade. There are different procedures involved: stripping and storing of topsoil. It means as the topsoil is very much good for the vegetation, that need to be removed and stored in some places, so that that soil can be used in later areas where there is a need of vegetation. Then once that soil is removed, definitely that compaction then the compaction need to be done to achieve or to get the required level of a subgrade. It means if it is a cutting section, then definitely that required depth of soil need to be cut, uh, and if it is an embankment section, that required depth need to be filled, and then compaction is done. In case of embankment construction or in case of filling, directly you can't fill the soil for the required height and then compact, as it depends on the type of compactors or type of rollers that you are going to use. If it is a static roller, definitely it will not compact the soil thickness more than 100 mm, and in case of vibratory rollers, it will not compact more than 250 mm thickness. No, it will compact but not to the required extent. So that's why if the thickness of soil is more than 100 mm, then that need to be compacted in different layers if you are using static rollers. If it is vibrant rollers, up to 250 mm in a single layer, that soil can be compacted. Or if it is more than, then definitely then there will be a need of more number of layers for the compaction. And the compaction is to be done for 97 percentage of relative compaction. This 97 percentage is calculated based on the lab density. Okay. Density requirements of embankment. See, before compaction, that soil need to be mixed with the water. when that water need to achieve the required optimum moisture content of that soil, whichever uh, it is calculated in lab. So once that optimum moisture is achieved, it is mixed properly, and then compaction, sorry, laying is done, and then compaction is done to get the required dry density. That required dry density will be 97% of the lab density. Say for the type of work, embankment up to 3-meter heights not subjected to extensive flooding, so it should not be less than 15.2 kilonewton per cubic meter. In the same way, there are different specifications given here. Now, compaction requirement for embankment and subgrade. For subgrade and earthen shoulders, 97 percentage of the lab dry density. For embankment, 95%. For other the subgrade and 50 mm portion just below the subgrade, it is not allowed, and for remaining portion it should not be less than 90%. So there are the different specification which need to be followed on site. In high embankments, as I told you, these are the different procedures involved based on the different situations of the project. In high embankment, resting of a suspect foundation as revealed by borelog shall be carried out in manner and to the desired depth, spreading materials in layer and bringing to appropriate moisture content. The embankment and subgrade material shall be spread in layers of a uniform thickness not exceeding 200 mm compacted thickness over the entire width of the embankment, and mechanical means finished by a motor grader and compacted. This motor grader is the one which helps to spread the soil to the maybe to the required slope, or it's having maximum uh, uh, features. The graders is having maximum features. It can uh, work for the required, or it can grade the soil for the required slope and required thickness. So that will help to achieve the required level, and then compaction is done by different modes. Moisture content of the materials shall be checked at the site of placement prior to the commencement of compaction. These are different procedures involved, just to go through that. Then for the what are the different types of compaction modes? Smooth wheeled, vibratory, pneumatic, sheep foot or pad foot rollers. Suitable size and capacity should be used for different types and grades of materials. Mostly compaction will be done by vibrate rollers of 80 to 100 kilonewton static weight or heavy pneumatic tired rollers. Each layer of material shall be thoroughly compacted to the densities in as shown in the table 1. Subsequent layers should be laid only after the finishing of finished layer has been tested. Means the required density test and camber test need to be done. The measurement of field dry density is recorded by nuclear moisture and density gauge. When density measurement reveal any soft areas in embankment, further compaction should be carried out to get the required density. The drainage, the surface of embankment at all times during construction shall be maintained at such a crossfall as will shed water and prevent pending. Repairing of damages caused by rain spillage. These are different measures that need to be followed. These are the different control tests that need to be conducted. So this is about uh, the preparation of a subgrade while construction of pavements.